Hello, this is Mr. McMurray, and welcome to the blood type worksheet. We're going to talk a little bit about genetics first. Let's do a little refresher. If you remember, when you get a gene or a trait from your parents, you get one letter from your parent or one allele, and you get one allele or letter for that trait from your other parent. All right, one male, one female. Now, when it comes to blood types, the blood types are having to do with these little markers that are on your blood cells. For example, these are considered A markers. Now, they're not really a little pointy knife looking things like that, but we're just using that for an illustration. If you have type A blood, that means you have the allele that makes these little markers on your genes, on your blood cells, red blood cells. Now, if you are type B, you would see these little round yellow ones, okay? And they have these little markers or antigens. They're called antigens. You see the word up here, antigens, okay? Those are those little markers that are type B blood, all right? So those are really the two traits that are involved in this. For a long time, they gave blood transfusions, and they weren't always sure why they worked sometimes and they didn't work sometimes, and thought, well, maybe we're just not doing it right. But it turned out that, in fact, there are these little markers. And these markers are how your body identifies cells as yours or not yours. All right. If it had the same markers as your red blood cells did, everything is good, the transfusion worked. But if they were different, your body might attack them as not being yours. Okay. So the alleles for this trait, then, you have A, which would give you the A-type markers. You have B, which would give you the B-type markers. Or it's possible you could be type O. Type O just means it's kind of like recessive. It just means there is no marker. Okay? All right, and there we go. So those are our three letters, A, B, and O. Now, but when you inherit these from your parents, you get two letters. So if you had A, and you got an A from your other parent, you would be type AA. And since both of your letters are A, guess what? Your red blood cells would be, they would have the A antigens on them, so you'd have type A blood. All right? But let's say one of your parents gave you an O. All right? Well, A is dominant to O, so you would still have type A blood. But you could possibly give O to your offspring and have offspring that has a different blood type. All right? So A is dominant to O. All right? With B blood, very similarly, if you have two Bs, or not 2B, sorry, couldn't help that. But anyhow, if you have two B's, big B, then you are going to have type B blood. And that's the little round yellow markers in our example above. But you're going to have that type of blood. If you have an O from one of your parents, you have BO, and you need to go take a bath. No, just kidding. Different kind of BO. In this case, B, once again, is dominant to O, and so you would have type B blood. All right? So that's pretty straightforward there. All right. Now, the question is, what if you got an A and a B? They were both dominant to O, so they are what we call codominant, which means if you have AB blood, you would have both A markers and B markers. All right. And if we look at a picture of it up here, it'd be like this one here. Type AB would have the A antigens, and it would have the B antigens on the blood cells. So you would have both of those antigens on your blood cells. Now, if you have O, well, if you get O in any other letter, then you're going to be the other letter. So if you have AO, you'd have A blood. If you have BO, you would have B blood. The only way you could actually have O-type blood is if you were OO. All right? That doesn't mean you're a real zero. That just means that you have both. Neither your parents gave you any markers, and your blood cells are completely clear of any antigens. All right, and that can actually be a good thing. When they're talking about donating blood, they very often like to have people with O blood. Why? Because if they give you O blood, there are no markers that say, hey, this is not the right kind of blood, and so everybody can accept this blood. All right. Now, in addition to the A, B, and O blood types, there was also they sorted that out. And they started doing transfusions, and they were working most of the time now, but there were still some times that they had issues with them. And it turns out there's another factor involved. There are little markers that are called RH factors. Okay? Now, the RH comes from rhesus monkeys, not Reese's Pieces, that's a whole different thing. rhesus monkeys, which is where they first discovered these, or in the rhesus monkeys, but they also found out they are in people. Okay, in this case, the positive Rh factor is dominant, and the not having it is recessive. Okay, and so basically, if you were, say, B positive, that means you, besides the B antigens on your blood, you would also have these little Rh antigens. If you were, say, O negative, then you would have neither the Rh factor ones, nor would you have the A or B, so you would have nothing on it. And therefore, O negative is considered the universal donor, because anybody could get their blood. There's nothing on it that would set up any alarms or thing to worry about. AB positive, on the other hand, would have all the markers. It would have B, it would have A, and it would have the RH marker on it. And so it can receive blood from anyone and is a universal recipient. So depending if you're giving, then O negative is great because you can give to people. If you're more selfish and you're more worried about what people can give to you, then AB positive is the type to have because everybody can donate to you. Now, let's get started on the actual worksheet. On the front page, the first part of it tells a lot of the information that we just talked about. Okay? And so, let's go at the bottom. You see a chart that looks something like this one up here at the top. It says blood type O, A, B, AB, and then it has Rh positive and Rh negative. So, here's the deal. In general, on average, this is a worldwide average. Okay? These are about the percentage of people that have each blood type. Notice B is not very common, only 12%, a little over 1 in 10 people. And since there's not very many B's, then there can't be very many ABs. Okay? And so AB is the least common, if you will. A and O tend to be the most common. Now, it varies a little bit. If you notice on the other chart that we looked at earlier, for example, American Indians have hardly anyone that has type B blood. And just in their gene pool, there's no one with that particular combination. And so they have an extremely low number of people with B and AB type blood. All right. In other cultures, you may have more A or more O. Okay. It just happens to depend on the gene pool, excuse me, of that particular country. Now, here's the deal. For the 4 blood types, O, A, B, and AB, that's how they spread out. A and O are the most common. B is least common, and then AB is even less common because it has to have B with one of these people, A. One parent has to be B in order for that to happen. Now, of the people for any blood type, 85% of them tend to have the positive or Rh positive antigen on the blood. So anytime you have a Rh negative, if you're like, for example, I'm A negative, then I am only one of 15% of all the people that have type A blood that have that. So negatives are always less common. So the very least common blood type is AB negative. All right. Okay, now what they want to do is on the next page, if you look on the next page, there's a chart like this bottom one here, and they want to know what percentage of people have each of these blood types. All right, so let's take this one. For O positive, well, we know that 45% of the people have O blood. So take that percentage, change it to a decimal, so it'll be 0.45 times the number of people that would have the positive, which we know is 85% of the people. Okay, so I'm going to multiply that times 85%. I could change that to a decimal, but then I'd have to change my answer back to a percent. So we're saying 0.45, 45% of 85%, and we would multiply that and get an answer. So if we take 0.45 times 85 equals 38.25. So we're going to round these off to have 1 decimal place, I believe. All right. So if we were to change that, that would be 38.3. So we're going to put 38.3% in that first blank. Now, mine's not the right size, but you will write it in the right size, so it will fit there, of course. All right. And then you would continue to do the same thing for each of them. So O negative would be 0.45 times the percent that have Rh negative blood, which is 15. And then you would round that off to 1 decimal place for your answer. And then we continue to do that for all the different blood types. When you get done, if you were to add them all together, it should be close to 100%. But because of rounding up or down, it may not come out exactly 100, but that would be how you would finish that chart. This chart says number 2, using the percentages, you can make a pie graph. You do not need to do that at this time. All right. If you're kind of bored and nothing else to do, by all means, knock yourself out. You can turn that in, but you do not have to do that. All right. The next section says talking about the blood volume. Go down to number 3. Okay. And this is one to figure out how much volume do you have of blood in your body. What's the volume of blood actually found in your body? All right. And this is just a formula. It says volume is equal to 70% times 70 times your weight in kilograms. Okay. And the volume would be in milliliters, which is thousands of liters. So you would just take 70 times your weight in kilograms, but the odds are you probably don't remember what your weight is in kilograms. So here's how you do that. To find your weight in kilograms, you just take your pounds and just whatever yours is. I'm going to be about 205 will be nice there, maybe more, but oh well. 200 times, sorry, not my, my bad, divided by 2.2, okay? And that will tell me how many pounds I weigh. Make that kilograms that I weigh. All right. So how many kilograms? What's my mass in kilograms? So 205 divided by 2.2, and that would give me a grand total of 93 kilograms. So I would probably round that to 3 sig digs, so let's make that 93.2. Okay, so 93.2 kilograms. All right. Then I would multiply that number times 70 to figure out how many milliliters of blood I have, and I would get 6,523 milliliters. All right. Now, if I wanted to round that to liters and do it in 3 sig digs, I could move my decimal over 3 places, and that would make it 6.52 liters. So in other words, about 3 2-liter bottles worth of blood. All right, which is a fair amount of blood. All right, and that's how you would find the first answer for number 3. Now, on number 4, it says, we know that blood is made up of several different things. Red blood cells are about 44%, platelets are about, or a little bit less actually, than 1%, and plasma makes up 55%. So I would take my answer, let's just say 6.53, all right, liters, 53 liters, and multiply that times, say, the percentage of blood cells, which would be 0.44, and that tells me for the first one, A for me would be 2.87 liters. So of my blood, I could fill up 2.5, give or take a little bit, 2-liter bottles with red blood cells. That's how many red blood cells I have, so that's a lot. Okay? All right, and then I would multiply for the white blood cells times 0.01 because it's a 1%, and that plasma, which is 0.55, and that would give me the percentage of all of those. All right? All right, the last page, front and back, has to do with inheriting blood types and also about whether you can give blood to someone or not and safely expect it to work or not. We only have about a minute and a half here to finish up on this video, so rather than trying to cram that all in there, I think we'll just try another one. All right, so that's it for this one, and make sure you come back for part 2 to learn how to do the second page.